Hi and welcome back. So in the last video we were talking about how many valence electrons all these different groups have, and I'll just write them in again. We said we had one valence in this column, 2 here, 3 here, 4 here, 5 over here, 6, 7. And then if we remembered, if you remember from the last video, we said that all of the elements essentially below this purple line all had 8, and I'll write them right here. We all had 8 valence electrons, and we said that helium wasn't included in I guess this classification of having 8 valence electrons, but helium is still considered a noble gas. And if you remember, I'll just say that actually, yeah, I'm going to circle this in orange over here. So all of these elements, which I'm going over in orange. So all of these elements are our noble gases. And helium is still considered a noble gas. And we touched on this a little bit in the last video when I think we did an electron configuration for krypton. And what we found out was that one of the really striking things, and you can maybe do some electron configurations on your own and realize this a little bit more, but one of the big thing that identifies a noble gas, or the big trait that only noble gases have on the periodic table, is that every orbital, every single orbital that a noble gas is occupying, or every single orbital that a noble gas has electrons in, is completely full. So in the past video we looked at krypton. Let's actually take a look at argon in this video. So let's look at argon. So argon, and I'm actually going to write out, I'm not going to use the nearest noble gas, nearest previous noble gas configuration. Let's just write out the whole configuration. So we say we have 1s2, 2s2, 2p6, 3s2, 3p6. This is the electron configuration for argon. And one of the striking things, or one of the, I guess, the trait that if we were to do the electron configurations for all noble gases, for all the noble gases, including helium, and actually, you know what, let's just do helium's. Let's do helium's electron configuration real quick because it's real short. Helium's electron configuration is just 1s2. That's all that helium's electron configuration is essentially that all of the energy levels, all of the orbitals that these elements have electrons in are all completely full. So we've got 3s2, 3p6, our third level, and we don't really consider the 3d electrons. We're mainly, I guess, I don't want to say that we're ignoring them right now, but they don't occur in this order that we fill our electrons in for the orbitals. But the important thing to realize is that all the orbitals and all these, I guess, energy numbers that we have, all the orbitals that we're using are all completely full. So, and the same thing goes with helium. And the thing is, when we're at our first level, when we're in our first period, our first shell, there are no p orbitals. So it's not like we have a 1p6 orbital. It's not like we have a 1p orbital that we can go and fit 6 electrons into. All we have in this first energy level is our 1s2 our 1s2 electrons. So helium, even though helium doesn't have 8 valence electrons, you could say that helium doesn't have room for 8 valence electrons, and that helium is perfectly stable and balanced with only 2. If you imagine, I know in the past video, and hopefully this analogy maybe worked a little bit for you, and if it didn't, I'm sorry, but I'll use it again, and maybe it'll work a little bit better. If you imagine our bicycle wheel analogy that I did in the last video about how if we have a bicycle wheel, and we put, and I'll just go ahead and draw, there's the center, and then here are all of our, just drew over my center, but there are all of our spokes. And if we were going to put reflectors on our bicycle wheel, essentially an electron configuration that Argon has, or what Argon maybe looks like, it's if you were saying that our electrons in Argon were reflectors on this bicycle wheel, is that Argon is completely balanced. So everywhere there's a reflector on this wheel, there's a reflector at the exact opposite point across from this this center of the wheel, this where the skewer of the wheel goes through. There's another reflector on the other side, so it's going to be completely perfectly balanced. Our Argon bicycle wheel. Maybe what you can think of, and this is just maybe a way for you to think of what an electron configuration for helium might be in this same analogy, is maybe it's just a really small bicycle wheel. Maybe it's a training wheel, or it's a wheel on a big wheel or something like that, or it's I don't know, a tricycle or something. And we say that so these are our spokes again, and maybe we only have room. Maybe we only have room. Over here in this analogy, we had 6 different reflectors. So we didn't. Maybe here I'll just add in there. Now we've got 8 perfectly balanced reflectors in our Argon-like bicycle wheel, and they're perfectly balanced, so the wheel is not going to vibrate at all. But maybe in this bicycle wheel for helium, we only have room for 2 reflectors. But still, the wheel is going to be perfectly balanced. So when you turn this wheel, it's not going to shake at all. It's just going to be perfectly balanced and still spin, I guess, the right way. So anyway, I guess I think I might end this video here, because really all I wanted to give you a sense of was essentially that even though all of these other elements from neon on down to radon, they are noble gases and have 8 valence electrons, helium is still a noble gas, even though it only has 2 valence electrons. And you can essentially think about that because that's all the space that helium has for electrons, and all the space is completely filled up and completely balanced, so therefore helium is happy, helium is stable, and helium, here's that word again, helium doesn't want to react. So anyway, in the next video, I am going to start getting into a bit more of the specifics of how these different elements might configure themselves a bit more, because, and here's the word again, they all want to get to a noble gas-like electron configuration. And in the next video, we are going to start talking about some of the specifics of how all these different elements do that. So anyway, thanks so much for watching, and I'll see you in a future video.